Next, I want to talk about these two graphs that we have here. The one on the left, it's identical, similar to the last example we did, where our quadratic graph crosses and touches the x-axis. Now, if you pay very close attention, here's my vertex, so at x equals 2. In the last example, we basically did the x value, one to the right and one to the left. So if I were to use this example where the vertex, my x is equals to 2, if I do 1 to the right, which is 3, and then 1 to the left, which is 1, at these x value, the graph doesn't crosses or touches the x-axis. So when that happens, that means you actually have to do 2 more points. So instead of just 1 to the right and 1 to the left, I actually did 2 to the right, so 3 and 4, 2 on the left, 1 and 0, so a total of 5 points. 1, 2, 3, 4, 5. Once you finish working it out, getting your y values, you see that at our 4th and 5th point, where x is 0 and x is 4, you see that the graph crosses the x-axis. So my solution in the left graph is x equals 0 and x equals 4. So I said it in class, and I'm going to say it again. Some examples, some problems, you might just need 3 points, including the vertex. Some problems, you might just need 5 points, including the vertex. Now let's take a look at the graph on the right. So again, to review, solution of a quadratic graph is when the graph crosses or touches the x-axis. Here, it open downs, but it can also open up, and what you see is that the graph does not touch, does not cross the x-axis. When you have a graph like that, and some of them will be like that, then the only thing you can write or say is no real solution. And you have to put the word real. So when you have a graph just like the one on the right, where it does not touches or crosses the x-axis, you must write no real solution because it's not touching or crossing. If it does, you do have real solution. Just like the one on the left, if you do have real solution where it crosses, then x equals 0, x equals 4. If you don't have that, simply write no real solution. That's it.